Good afternoon, everyone. Welcome to CAD Technologies. Today, in this video, we'll be seeing a simple basic tutorial. This was a simple component which was given as a tool test to one of our students. So, before delaying, let's get into how to make this component using CATIA as our CAD tool. Now, first, let us try to figure out where our origin point or our 0, 0 is. Actually, this location is our 0, 0. So from here, let's try to begin making a model on either towards this side or towards this side. So I'd like to start by making this shaft first and then slowly go ahead by making these complete features. So since it's a part modeling module, you can go into your mechanical design, you can work on your part design. Under your part design, we will be only using commands of your groove and of your shaft and your groove. There will be no other commands to make this model. You can use your hole for this feature, which is a pretty much a very simple feature which you will be learning in the first session of your 3D modeling. Now, to begin with, let's start by making this as I've already mentioned. Again, since we are using shaft, make a sketch, select the plane. Let us first make the axis. We already know that this is the axis. We'll take the axis. Now, we need to make half of this to create a simple cylinder. Let's try to do that as well and start dimensioning our profile. So from the center, the end is actually at a distance of 65, which is already given. This distance is actually 16 again, which is already given. The overall diameter is 120, again is already given in your drawing. You can make all in one go, no problem. This might hinder the profile, so I'm doing it one after the other. This is the first cylinder. With my reference of this cylinder, I'd like to make the complete rest of the shaft. So using my shaft again, I'm using this as my reference. Let us select the axis as usual as well as our edge reference, which I'll be using to make the model. I can directly use a profile command, but before that let me try to create a simple 95 diameter circle so it won't create an issue later on. This is your diameter, this is your 95. As you can see, this is the 95. Now this 95 should actually be in line with the new shaft which is coming. I'm sorry, this is supposed to be diameter 95. This in line with the shaft. So let's try to take a line from here and make it in line with this, and the diameter for this is actually given as 56. So let's try to take that as 56. Now these two should be joined together. I can use coincide, no issues with that. From here we do have a continuous profile which goes this way, which is a slanted one. So let me try to take that too. This is a slanted one and it actually goes this way. It's a very simple profile, and then closes till here. Let me try to close the profile in one go. Now let's try to start dimensioning. First, towards the end it is supposed to be 65. This is actually supposed to be 140. The dimension of this and this are the same. It's a typical dimension, so I'll give that first. Now towards the end it is supposed to be 65, that is from point to axis I'd like to give 65, and the inner circle as well has a particular dimension. This is 56. Let me try to give it as 56. Now the remaining dimensions are our distances etc. from 0, 0. So from here till here we obviously require a dimension which is 230, and this one is again 16 which is given here. So as you can see, the whole profile is completely constrained. Let me try to check if these two are joined. They are. Once I exit, it will try to create the shaft as you can see. You can do one after the other. You can make this, this and this, or you can make the whole component in one go as well. There is no problem. So before making our internal cuts, let's try to make the remaining part of a model as well. So from here at a distance of 90, we do have a circle. So we cannot keep two parts hanging in the air like that. So we'll try to make this first and then make the top one. To do so, we require a reference. So again, I'm taking a reference at 90 first. Now below that 16, we do have another one. So again, reverse the direction, take it at 16. On that 16, let's try to create the circle. The inner circle, as you can see, is 56, and the exact location of the center is the center of your cylinder. So let's try to take this as 56. Now exit, you have to add it up to the next surface it can find, so it will. Again pad, I have to add 140 on this plane. You can take the plane below as well, no issues, whichever you're comfortable you can. And this should be added only up to the next surface it can find. So if I say up to plane and select the plane, it should be okay, it will add till the plane. Now, the process of removing the material internally is actually called shaft groove with respect to an axis. So again groove, I am selecting the front plane. Here I would require an axis, so I am trying to use an axis, and now I'd like to use these two ends as my references, so I'd require to remove these materials as well. Similarly, I want the circle reference, so I can make this 8 cut. So for that, I'll be creating a circle here and giving the same dimension as it actually has, which is 95. Because I want this 8 mm maintained, I'm trying to do so. Now let's try to make a profile. It starts somewhat this way. Has to be straight and then goes down, and it should go touch with the circle on the inner side. So I'm just not doing that at the moment. Let me try to dimension this before we go further ahead, because there are less dimensions than what I have sketched. This is supposed to be 50, you can see it here, and the inner one is supposed to be 40. Now there is 8 mm offset. Let me try to take the offset using the offset command of this to 8. We do know the dimension between these two is supposed to be 8. Got constraint somewhere. Supposed to be 8. Now it need not be till here. I'll trim it off later. Let us meanwhile trim only this small area. It does not create an issue. And we know the length of the internal cut, which is this, as 5. Now from here we do have 8, which is over here. So let's try to take that from here, which is 8, and then slowly goes up this way and then follows a slant till here and then closes this way. This is the actual cut which we are supposed to make, but we'll be dimensioning it one after the other, just not going very fast. The length of this is 8 and the diameter of this is really important, which is 37. So let's try to take that as 37. Now the outer one, which as you can see is 44. So the outer point I'd like to take with respect to the axis is supposed to be 44. You can do it one after the other, or you can do it in one go like how I'm trying to do. Either way, both are correct. This one again is the internal cut, which is 48. So let's take that as 48. And we know this is 5. And the diameter for this is 55. Again is already given there. I'll just show it to you. This is 55. This is your internal sketch. Now let's try to trim off whatever we do not require, which is the extra circle and all this side of your sketch. Now this way, I'll probably have to constrain these two again. This way you can see that the profile is done, and you can maintain, you can see that it is completely constrained. And now when I exit, it usually tries to remove the material from the internal body. We do have a small hole on the top, which is 40. Now let's try to do that as well. It has to be positioned and maintain concentricity as per feature based modeling, and give it as 40. Say okay. This is your cuts. This is a very simple model. We do have few rounds. Let us try to give those as well. This is the first one. We do have one here as well. Sorry, not to the full body, just to this edge and this edge and this edge and this edge, as well as the top face. basically no sharp edges. Let's try to take this and give it a 6. This is your final shaft model of your model here. You can see the section view if you want. It does exactly look like how the view is. I can show you the front view once. This is your section view. Meanwhile, if you're looking for any complex videos and advanced level of training, you can always contact us. Our details are given in the description below. Meanwhile, please like and subscribe to our channel, which gives us a little more encouragement to post complicated videos like the ones you are seeing today. Thank you.